this is what your notes looked like last night, and when I left the notes, I wrote this on Canvas. I don't know if you noticed it or not, but a little after 7 minutes, I made a false statement in the video. The false statement was, hey guys, we're only really going to deal with parallelograms. And at the time I made the video, I thought that parallelograms was all they really tested you on, and then since then, I have been corrected that no, in fact, there are more than just parallelograms. Well, technically rectangle, squares, and a rhombus are specific types of parallelograms, but I had been told that those three things were not really tested, but they are. I have since learned. And then I learned even more that trapezoids and kites are sometimes on the test. Anyway, so what we're going to do is we're going to take this sheet, we're going to flip it over, we're just going to add a few details about trapezoids and kites. Now, trapezoids and kites are not parallelograms. So we're going to write, on the back of the sheet, we're going to write other, and they are not parallelograms, but they are quadrilaterals. Anyone know what quadrilateral means? Yeah, four-sided shapes. Lateral means side, so quad, 4 sides. Other 4 sides. So we're just going to add 2 more shapes in there. Just make sure that if you run into them, you will not be like, whoa, what is that? I haven't heard about that since elementary school with my blocks. You know what I'm saying? That was my favorite blue block. And other than that, I haven't seen it in a long time. You know what I'm saying? Okay, so a trapezoid has one pair of parallel sides. One pair of parallel sides. So there's a picture of a trapezoid. It might not be the picture of a trapezoid that you're used to seeing, but that's okay. This is a real picture of a trapezoid. And then there's another type of trapezoid, if you're going to be more specific, that's called an isosceles trapezoid. Where else have you heard the word isosceles? Triangle. Okay, so isosceles trapezoid is probably more what you're used to seeing pictures of. Trying to be careful and maybe draw it the way it should be drawn. Isosceles trapezoids look like that. So these sides are parallel. That's what the markings mean. So in an isosceles trapezoid, these sides are parallel. But just like an isosceles triangle, these sides are congruent. And then because those sides are congruent, these angles are congruent, and these angles are congruent. Yeah. And then what is more interesting is that the 2 angles together are supplementary. That's pretty interesting. And then the other thing that's kind of interesting is that the diagonals are congruent as well. So isosceles trapezoids have all sorts of weird stuff about them. Yeah, you can move it. That's fine. You're good. Okay. All right, and then we have kites, which you fly at the beach, but then they're also shapes. So I draw the inside first because I think it makes it easier to draw. That's right, so why is your kite so much bigger than your trapezoids? I don't know, get off my back. Okay. I didn't either. I like to ask the questions before you guys do, just so that you can't. All right, so here's the kite. So in a kite, these two sides are the same, and these two sides are the same. These come together at 90-degree angles. These are called diagonals right here. This diagonal down the middle, it cuts the other one in half. The long one cuts these two angles in half. So that's kind of interesting. And then this angle over here, the whole thing, this whole angle and this whole angle are both the same. I think that's everything. Okay. What about the bottom? Oh, that these are. Yeah, those would be. That should be bisected too. All right. I think we drew everything. It's good. Okay. So, not as common, but you'll run into stuff. So, there we go. Okay. So, you have some notes you can refer to in case we run into things today. So let's go ahead and we're going to look at our parallelogram notes continued. So these are our facts about parallelograms. This is going to be kind of like Wednesday, where we had one set of notes that had facts, and then we have this other set of notes that has mathy stuff. So these are our mathy notes. Okay. So now these notes are specifically related to parallelograms, but you can certainly apply these ideas to other types of problems. It could be applied to trapezoids. It could be applied to the specific parallelogram that's a rhombus. It could be applied specifically to a parallelogram that is a rectangle. It could be applied to something else. But all of these are just regular old parallelograms. So right now I have two angles that are next to each other. We would call these consecutive angles. So let's look at our notes and see what we know about consecutive angles. What do we know about them? They are supplementary, which means what? They add to 180 degrees. So we are going to say 10x minus 12 plus 72 equals 180 degrees. So that is going to be the equation that we solve to do the first problem. Does that make sense? So consecutive angles are supplementary is the math fact that we use there. Consecutive angles, I'm going to go ahead and write that. Consecutive angles are supplementary. Okay, so negative 12 and 72 gives me 60. Subtract the 60 over. X equals 12. All right, example number 2. What math fact about parallelograms are we using for example 2? Opposite sides are equal in length. Or you could say they're congruent, either way. So we're going to say 5x plus 5 equals 20. We'll go ahead and solve for x minus the 5 over. 5x equals 15. X equals 3. Okay? Miss Rice, what a fun use of a Friday. I know. What a great time. I'm having a great time. I stayed up 2 hours past my bedtime last night reading a book. I try to go to bed at like 10 or 11. I stayed up after midnight. It was the Tierling book. You guys liked how the other one was like, okay, well, the other one cost $14 and this one was free. You guys missed the power of the They don't deserve the yeah. Okay, I will, before the end of the period, you guys, before the end of the period, I will write down what brand it was. I found it on Amazon. It's just $14. The stapler I have, it broke. The broken one. No, it's in my desk. It's just broken. Yeah. All right. It is broken beyond fixable. It's yeah. A freshman happened to it. I have no idea. They did freshman things. Right. I like how I said a freshman did a freshman thing to it, and you guys nodded in understanding. We get it. All right. Apologies if there's any freshmen in the room. I have no idea how old you guys are. Okay, so what math fact can we see in example 3? Math fact. Opposite angles are congruent. Opposite angles are congruent. All right, I'm writing this down because notes, it's good to have your notes make a lot of sense. Opposite angles are congruent. We like it when our notes make sense. Opposite angles are congruent. So I'm going to say 17x plus 8 equals 19x minus 2. All right, minus the 17x. Then we're isolating the 2x over here, so I can just add the 2 over to the other side. Divide by 2. All right. What math fact are we using for example 4? XG and EG. Are we even using a math fact? Oh, we kind of are. We are. What are we using? Anybody know? Yes. No. It's not an angle. What are these things called? Yeah, diagonals bisect each other. All right, so if xg is 12, what is xe? If xg is 12, what is xe? 12. And I know that because df bisected that diagonal. It cut it in half, so the two halves have to be the same. The reason I know that is because it bisected it. Does that make sense? Okay. So now I can go through and I can say e.g. 13x minus 2 equals what? 24. All right, so I'll add 2. 13x equals 26. And then I'll divide by 13. X equals the back of Joseph's head. What did you get? Marvelous. Thank you. Thank you, the back of Joseph's head. Joseph, I wasn't talking to your face. I was talking to the back of your head. Thank you. I don't know why he turned his face to me. I was talking to the back of his head, so clearly rude. All right, example 5 is going to be an interesting one. We're going to have to think back to Math 2 to figure out what math fact we're using for this one. Anyone know what math fact we're using? The question mark is 96, but what math fact are we using? No.
Consecutive angles are supplementary.
No.
Consecutive angles are equal.
No.
They have the same length. Yes.
Sam. Did you just raise your hand to say, I don't know?
But like, common sense.
It's not common sense. They are called alternate interior angles. Okay, but what? No, but no one has told me the math fact. There's a math fact on here that we're using. What's the math fact? Parallel lines, but what's the parallel lines? Opposite sides are parallel. Okay, so what we're using is that the opposite sides are parallel. This is referring back to Math 2. In Math 2, you learned about two parallel lines and a transversal. Here's our two parallel lines. Here's our transversal. And if we have two parallel lines and a transversal, the alternate interior angles are congruent. Now, we learned about all sorts of other angle relationships too. We learned about same side interior, same side exterior, alternate exterior, blah, blah, blah. The only pair that seems to be used in a parallelogram is the alternate interior. So this is pretty much the only deja vu moment you're going to have with Math 2 in regard to two parallel lines and a transversal is going to be just this, alternate interior. But that's the math fact it was referring to, is that if the opposite sides are parallel, we can all of a sudden take the opposite sides that are parallel and one of the diagonals, and we can use what we learned in Math 2, two parallel lines and a transversal. Does that make sense? Okay. All right, let's reach back further. How do we find the distance between 2 points? Nope. Well, yes, we can count some of these, but what about this? Yes.
You have to find
that is accurate.
one y to the other y.
Uh-huh.
You have to add all of them together
that'd be like 7.
Add average, double it.
Joseph?
Add the absolute value.
No.
That's dumb.
But that seems to say
Maybe the distance formula?
What the heck?
that's what Lucas said. Oh wait, is this the C thing? I remember Miss Lopez teaching me this. I don't know what it was, but I do remember her explaining this to me.
It's a D. The distance?
I don't think Japanese.
Wait,
It's not that much math. Wasn't she in here when? No.
Can you take me to? I was right.
This is right.
All right. So to make sure, yes.
How does 1 square get rid of all of the squares?
This is the Pythagorean Theorem.
That's
Well, think about it. If I want to know, listen carefully. If I want to know how far apart those points are, that's the hypotenuse of a triangle. Yeah, it's just the Pythagorean Theorem. That's all it is. You guys studied this. You already been done this. This is math 2. Don't tell me it's not, because I'm teaching math 2 right now. Okay, this is not new. Okay, so we can tell this is a parallelogram because these two sides are perfectly horizontal. Does everyone see that? So I know that these two sides are parallel because they're perfectly horizontal. Then these sides go up 1, 2, 3, 4, 5, 6, 7, and over 2. Up 1, 2, 3, 4, 5, 6, 7, and over 2. So if they have the same slope, they must be parallel. Okay? So I can already tell just by looking and counting boxes that these two sides are parallel, those two sides are parallel. Now I just need to see how long all the sides are, okay? Now, they gave us a nice example because we can just count boxes on the top and the bottom, so let's go ahead and do that and see how long these sides are. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Top and bottom are 13? Yeah? Okay. So now, we're going to find the length of AD and we're going to find the length of BC. We're going to use the distance formula to do it, okay? So AD, BC, okay. It doesn't matter, so it says x2 minus x1, y2 minus y1. It doesn't matter what order you do it as long as you're consistent. So I'm going to start with this one, and I'm going to do x minus x, y minus y, okay? Okay, so I'm going to say -7 minus -9 squared, 5 minus -2 squared. So I wrote -7 minus -9 squared plus 5 minus -2 squared. Okay, and then for BC, I'm going to say 6 minus 4 squared, 5 minus -2 squared. Okay. To make it a little bit easier to plug into my calculator, I'm going to take the minus minus and make it a plus. Take the minus minus, make it a plus. Take the minus minus, make it a plus. Okay. Everyone good? We comfy? That wasn't so bad? Okay. Because I'm just telling you, I've been a high school teacher for a minute, and this has never been in the high school curriculum, which means you guys did it in middle school. That's why we don't remember it, because it was a long time ago. Okay? Middle school's a long time ago. Okay, so I got a big square root sign. -7 plus 9 squared. 5 plus 2 squared. Okay, we good? I'm not worried about typing the square root because this is not going to be an I. Right? I'm not going to get a negative under a square root. This is an actual length of something. So this is going to be a good answer. Well, it might be a decimal, but it's going to be not negative. Okay, so 7.280. Should the other answer be the same or should it be different? Should be the same. We're making sure they're the same. If it's a parallelogram, they should be the same. Should be the same. Yeah. Square root 6 minus 4 squared. 5 plus 2 squared. Whew! Thank goodness. There we go. $7.280. All right. How are your brains? You feeling good? Okay. All right, now we're going to add one last example on here. Somebody give me a school-appropriate word, 4 letters long, no repeats. I know. School-appropriate word, 4 letters long, no repeat letters. Duck. D-U-C-K. Okay, we're going to draw a parallelogram, duck. You better not change it on your papers.
D-E-A-T.
All right. Now, this is what messes up students when they label their pictures for geometry-related work, okay? You do not get to label in whatever order you want, okay? You do not get to go D-U-C-K. You don't get to do D-U-C-K. You don't get to do that either, okay? You start on any corner you want, and then you go clockwise or counterclockwise, but you go in a circle. You do not go in a square. You do not go right, left, right, left. You go in a circle. Does that make sense? Okay. So we are adding this to our notes because I've had students get problems wrong on the test because they mislabeled their picture because they did not go in a circle. Does that make sense? You'd think that it would make sense, but people mislabel their pictures all the time. So we do D-U-C-K. We go in a circle. And I do want you to draw out that circle because I want you to remember, if you ever have to draw a picture yourself, that you go in a circle when you do this. Okay? It can be clockwise, it can be counterclockwise, it's got to be a circle. Okay? Because when they have this, they're expecting the U and the K to be across from each other. They're expecting those to be opposite angles. They're expecting the D and the C to be opposite angles. If you do D-U-C-K, then you were drawing it wrong because you made the wrong opposite angles. Does that make sense? So we always draw them in a circle because that's the way that they're meant to be drawn. It doesn't matter which one you start with. You start anywhere you want, you draw in a circle. Okay? All right, any questions? Okay, so we got a worksheet to do and we got a scavenger hunt.
In the worksheet, I already looked around and there was some question that was on the worksheet that was on the scavenger hunt.
That could be a coincidence. So the worksheet is only parallelograms. The scavenger hunt is quadrilaterals, and it involves more than just parallelograms. So it's possible that one of the problems is in common, but not likely that there's more than one duplicate. There you go.
So much fun being an immature little game.
Hold on. Punctuation.
Oh, what are you gonna do? Exclamation point, period.
Yes. It is on my desk.
I know, but it's like 20 minutes. My sign got no, my dad. Oh, like that one little word, and he's got one chunk. I remember that was